Before heading to our first coffee break, I have an honor to invite co-founder and CEO of IT from Bit, Bruno Segvic, to close the first block of speeches. He will present AI in retail, advancing promo demand forecasting, highlighting how AI-driven forecasting transforms retail operations from enhancing promo timing to optimizing supply chain agility, all aimed at improving profitability and customer satisfaction. Bruno, please join me.
Hello everyone, thank you for the announcement. My name is Bruno Segvic and I'm a CEO and co-founder of It From Bit, a Croatian-based company that's providing services in the field of data science, decision science and data engineering. And today I will talk about the advancing the promo demand forecasting in retail. I believe that many of you still remember, not so long ago, during the pandemic time, when some of the people were stockpiling flour, some of the people were stockpiling toilet paper, and others were stockpiling wine, which is a good idea if you ask me. This was not a dramatic situation just for the retailers, but just for the customers, but also for the retailers, because there was a sudden surge in the demand, and they didn't have enough inventory to respond to it. Certainly, as a retailers, you probably face the situation with excessive inventory, which often led to write-offs, and at the end, significant capital tied up in the stock. The retailers who decide to use the traditional methods of demand forecasting are making usually the error in the demand forecasting, which is causing them to lose almost 500 billion a year in lost sales and the significant capital tied up in stock. In order to make that error smaller, the AI solution had to be implemented, and the ones that decide to implement AI solutions can expect the average reduction of that error by the 50%. Today, I'm going to showcase you how the AI-driven demand forecasting is becoming the key tool in order to optimize business and attract new customers, and how we at It From Bit implemented this solution for one of the leading retailers in the region, which eventually caused them to reduce this forecasting error by 60%. This was a huge project because it took a wide range of the products, and it had to be implemented over the more than 400 stores, over the network of more than 400 stores. So alongside that, the other side and the other goal of the project was to empower the retailer to be able to make a decision for optimal trade-off between the overstocking and the stockouts. So during the whole this journey, we encountered several challenges, and I would like to highlight 3 of them, which is, first one is data-related challenges. So in order to make decisions precisely and effectively, you need to make those decisions data-driven. On most educational AI and ML courses online, you will work with clean, clear, and well-structured data, which can lead you to misconception that this is how it's going to be in the reality as well. But in the reality, data is not clean nor well-structured. There is high sparsity in the data, irregular sales patterns, and very low demand visibility, which is making these predictions much harder to achieve. Then we have the strategic and the tactical considerations. After we managed to solve all the technical issues, we had to make decisions based on those data. And one of the key elements of how the retailers is going to remain competitive on the market is to do the promotions. And this created a certain promotional spiral, which led to customers buying products exclusively on the promotions. So the job of the retailers were to present exactly the product that shoppers want at that particular time. Eventually, 2 out of 3 Europeans are going to buy these products in the promotions. In the Croatia, we expect this number to be much higher for the obvious reasons. And the 3 key questions in the tactical strategic considerations were how to choose the right product for the promotion, how to plan the inventory during the promotional periods, because you want to achieve the optimal level of the stock, so you're not left with overstock after the promotions, or you don't want to also face the stockouts. And as well, the third challenge was to manage the risk of the dynamic market changes during the promotion. So you need the flexibility, because the outside factors such as government restrictions, actions from the competitors, or seasonality can all affect significantly on the successfulness of the promotional campaign. And the third key element is organizational and the human factor. After we resolved all the technical issues, in order to have a successful implementation, is that we need to change the organizational culture and the mindset of the people. Because if the people are not going to use it eventually, the implementation is not successful at the end. To manage all of these challenges, we used advanced machine learning techniques and statistical methods. And during this project, we encountered several key technical challenges. The first one was working with extremely sparse and irregular time series. This meant that during the past promotions, certain products were not on the promotions regularly, and we had huge gaps in the data. So this didn't allow us to clearly feed the models in order to predict the demand of the certain products. This was particularly important for the products that had very low demand and seasonal variations. The second one was cannibalization or demand transference. This was the phenomenon that occurred that at the point when we put some of the products on the promotion, it affected on similar and complementary products that they were in the low demand. So basically we figured out that we don't need to only model the customer behavior towards products on the promotion, but also how this promotion is affecting the broader range of the products in the store. The second one was demand visibility. So since in the past promotions, there were some products with extremely low demand, which are called the long tail products, and we had the huge gaps in the data, and we couldn't feed the model to get the correct results. In that case, it is a possibility to use some external data, such as data from the online sales. But we decided to go the other way, and we used the techniques of statistical inference and the data from the similar products and the categories in order to see what would the actual demand look like if stockout didn't occur at that moment. In the terms of the categorical variables with extremely high cardinalities, we had many stock keeping unit IDs, which cardinality was measured in thousands. And if we feed the model with those SKU IDs directly, that would mean that each ID would be its separate category. That would lead to the generalization and the poorer results. To overcome that, we decided to use the encoding and categorizing under the certain features and characteristics, such as, for example, electronics or snacks. And the last one was the risk management arising from uncertainty. Here I would like to emphasize that this is about uncertainty and not insecurity, because we use the frequentistic approach of conformal prediction in this case, and not the Bayesian approach, which is telling about the insecurity degree. In order to clearly predict the stock levels, it's not enough to use the point predictions, but we had to use the distributional predictions or the predictions on the critical fractals in order to get the quality of the results. This means that it's not enough also to just have the averages of the demand of the certain products, but also to understand the risk of stockouts and overstocking. In that context, with our solution, we didn't provide just the average value, but we provided the probabilistic scenario of the possible outcomes. In that case, we equipped the client to make its own decision based on the tolerable risk. So, for example, during the promotion, we were able to say, okay, this product has a really high chance that will be in high demand. But even in that case, the retailer was the one who will have to make a decision how much he wants to stockpile of this certain product. This decision is not always easy to make, but at least it's made on the tolerable risk. In order to overcome all of these challenges, we used many techniques and some small technical innovations. And to name a few, we used the gradient boosted tree models, concretely light GBM, which was a perfect way for working with such a sparse data as it was in this case. The speed of the light GBM led to faster experimentation and the data analysis, which allowed us the faster pattern discovery. Then, incorporating cannibalization in the feature engineering. This was also very important because we could model the impact of the cannibalization on the similar products within the same categories. Then we also used adjusting and filling gaps in the sparse time series. This was important because in this way, we were able to get much richer descriptions of the product that had really low data quantities. And by that, we managed to feed the models with more data, and models will be able to use some advanced pattern recognitions. Quantile conformal regression was the go-to method for quantifying the uncertainty. Of course, we developed as well the special variant of the cross-validation, which was important in a way that if we use the standard cross-validation technique in this case, it would cause the data leakages, and the overall process would have poorer results at the end. During all of this process, we generated a couple of hundreds of features, from which we choose only about the 15%. And we choose those features using the wrapper methods, Borout, and sharp list values. The custom training pipeline was developed in order to combine on the statistically correct way the encoding techniques and the tailored cross-validation in order to get the better performance at the end. After we solved all of the technical problems, we come to the strategic and the tactical considerations. Since the promotions are now the key tool on how to stay competitive on the market, and that led to the numerous promotions, here the retailers had to make the three most important decisions, and this was the selecting the right product for the promotion, planning the inventory levels during the promotions, and tailoring promotions to the market conditions. For selecting the product, we were analyzing the patterns from the past campaigns, and from there we could give the results to the retailer, and from there he could choose the products with the highest potential to be included in the promotion during this time of the year, during the specific time of the year. And this was enough to create the range of the products that will be included in the promotion. Then, after that, the planning the inventory levels. In that case, the retailer had not only to figure out how much of the certain product will be sold during the promotion, but also to choose, to make a decision of the best balance and best trade-off between the stockouts and the overstocking of the certain products. And the last one was tailoring the promotion to the market conditions. For example, lots of government restrictions happened, especially during the pandemic time. Competitor is having their promotional activities, and also the seasonality are the factors that can affect the promotion. So if the retailer wanted to launch a certain promotional campaign, they had to take all of these factors into consideration, and they could respond in several different ways. For example, reducing the price of the product was not always the right answer and not the only answer. But, for example, if the competitor is having the promotion of the certain beverages, our retailer could extend the promotion by including some snacks to pack with the beverages in order to provide more value to the customers. Also, he could, for example, include some loyalty points on top of everything, which would be communicated in advance during the promotional campaigns. So the buyers would clearly see the additional value in that retailer in respect to the others, and decide to go and buy some stuff at their place. So these are all some tricks that can be done. On top of that, one of the very important reasons for the successful implementation of the solution was the organizational and the human factor. For example, if we overcome all the technical challenges, but the solution at the end is not used by the people, we cannot call it a successful implementation. So how to overcome the skepticism of the people and the resistance to the new techniques in the company? Well, people often see the AI tool as something that's going to replace them, that threatens their workplaces, etc., which is not something that surprised me, because many studies shows that the most common way of the AI solution failure is that the technology is not aligned with the people that are using it. So how can we ensure the successful adoption of the AI solution within the organization? First, we can define a small pilot project which can be done with 3 to 4 months time. We can be implemented within the 3 to 4 months time. In this case, the people could see the results rather quickly, and they could test it by themselves. In this way, they would not feel pressured to use the solution, but they can familiarize themselves with the solution gradually. In our case, this led to skepticism being transferred to curiosity, as they saw that the solution will help them to make the better decisions. The second one was establishing collaboration between the departments. This was very important because within the organizations we have silos as the departments, such as sales, IT, marketing, And when it comes to sharing the data and the responsibility between them and prioritizing things, certain disagreements arise. So dissolving these silos and structuring clear communication between the departments is going to ensure the faster implementation of the AI solution. Transparency was also very important because usually people don't know on what way AI solution came to a certain results. That's why we put a high emphasis on explainability of each and every result that came from the prediction models. In this case, when the people could see what were the steps and how the certain result arised, they become more confident, and basically they didn't feel anymore like they were following just the black box, but they were able to also actively participate in the solution tailoring. At the end, the AI solution didn't replace the customers, didn't replace the employees, but it empowered them. They didn't need to use many hours for inventory and stock analysis, but they could use their time more on some more complex tasks, such as strategy and optimization of the processes within the company. So, in the conclusion, the retailers who decide to use the AI solution will definitely be able to stay competitive on the market. But they have to have in mind that for the successful implementation of the solution, the go-to steps are to implement it with a pilot project at first, to have a clear transparency within the departments in the organization, and to have transparent and well-structured communication. The retailers who implement these solutions have to have in mind that overcoming all of these technical challenges is not going to be enough to have a successful implementation, but they will have to change the mindset and the company culture. Thank you very much.
Prova? Yeah. Thank you for sharing your experience. And I want to ask one question about technical challenges you overcome or encountered, because I didn't see anything about lead times. When I had to deal with this kind of problem, one of the most hard challenge to solve for me was lead times. I want to ask if it was not present for other reasons, or if it was not a technical challenge in this case.
As far as I know, it was not a technical challenge in this case. I didn't have a hands-on on this project, but we can discuss it afterwards with the person that was working on this. So yeah, we can discuss it, because no, I was not aware about this challenge with the lead times.
Okay. The point is that when you try to estimate future demand, you had to do, at least in my case, in the lead time period, no? Because you have to set reorder points based on lead times, and often you don't know lead times. I'm talking about purchasing lead times, so time needed to purchase items. But it's not maybe related to all markets and so on. I don't know, this is a producer or...
I mean, usually, so the demand prediction is based on the part of the year and the products they see best fit for this promotion at a certain point of the year. But they are not, as far as I know, including. I don't think that. Yeah.
We can talk after with.
We can talk about it after, but
yeah.
Yeah.
Thank you.
You're welcome.
Hello. Here. Thank you for your presentation. I have a question about the promotional data. Did you have categorical promotional data and numerical, like price? Or what was the type of data that you, because we usually come across both of them and we have to kind of tackle them differently. And also, did you try to predict the price of the item according to the demand? Thank you.
Thank you for the question. The pricing itself was a different separate project from this one, and there are many challenges occurred there with defining the prices of the product, and they didn't manage to successfully implement this because the predictions for the prices were ranging a lot, so it was not useful for defining the prices. That is regarding the pricing, so that was not included. They used the standard rule-based model that they have in-house for these price definitions. And regarding the categorical variables, I believe that I mentioned in the case of a demand, in the case of the prediction, we encountered with a lot of products that were like their separate categories. So we used some way how to encode and group them based on some other characteristics other than just the product stock keeping unit IDs.
Thanks for the talk. It was very interesting. I have two questions. So you mentioned first that you used LightGBM model for this prediction of stock and demand. My question is, do you use one large model for all of the products, or do you use one model per product? And if you have one big model, do you use then just, I don't know, some features of the products and something like that? And the other question was, how was this solution deployed? Did you set up some API that this retailer then used in their software, or was it some dashboard that their customers use?
So what I can say to you that the LightGBM was decided to be used in the context because there was a high sparsity of the data, and it was more inferior to the CAD boost in this context. So that was some high-level reason why they used it, to have a more in-depth discussion. I'm not able to enter that. And for the second question, sorry, what was the second part?
How was this solution deployed? Did you use some API that then
yes,
used?
it was all deployed on the GCP, on the Google Cloud Platform, using the APIs.
So then they use it automatically, and
yes, yes, this is automated.
Hi, thank you for the presentation. I have one maybe a bit specific question, because you mentioned that you developed the custom tailor-made cross-validation for this project. I just wanted to know what was the reason behind not using like standard libraries and standard techniques like rolling window for time series or blocked rolling window. What was the specific thing for the data that caused you not to use like basic standard types of cross-validation?
Standard variant of the cross-validation in this context would use the data leakage. That's why we optimized and customized the whole process.
But like the rolling window for time series, I don't know exactly what was the problem for the data leakage to occur, for you not to opt to use the standard. I mean, what exactly, can you maybe explain what exactly would cause the data leakage in this context?
Yes, like I said, we could discuss about that later,
okay.
because I was not working on it, but I knew this was the main reason why it was used, why it was customized at the end.
Okay, thank you a lot.
Yeah.
Bruno,
Yes.
well done. Thank you very much for joining. Please, round of applause.